Yes, welcome to the lecture series of applications of partial differentiation. In applications of partial differentiation, how to find Jacobian? Because Jacobian is very useful in engineering. In phase transfer, the Jacobian is highly used. Then some optimization we have done. We found maxima, minima of the function. If any function is given, either implicit or explicit, so how to find out maximum value of the function, that is called maxima, and minimum value of the function, that is minimum. Saddle point also we found, because saddle point is the point where function is neither maximum nor minimum. Later on, the Lagrange method of optimization we studied. Now, in this lecture, some problems on Lagrange method we are going to discuss. In Lagrange method, function will be given to you, and that function is defined on particular condition, or either you can say condition or constraint. And that constraint is equality constraint. There may be the constraint which are inequality constraint, which is out of scope of your syllabus. But when inequality constraints are there, very popular method, that is simplex method, we can use. Nowadays, non-traditional optimization techniques also exist, which are not gradient based. Those are genetic algorithm and colony optimization, simulated annealing. So these kind of non-traditional optimization techniques are also available. It's many times the fuzzy logic is also used to optimize the thing. But all these things, non-traditional optimization technique or simplex method, it is out of scope of the syllabus. As per syllabus, so we are going to discuss one of the important optimization technique, that is the Lagrange technique, or you can say the Lagrange method of maxima minimum. Now, in Lagrange method, in short, I tell you what happens. The function u will be given to you. Okay, any function u will be given. You will be given function. And you will be given the condition. You can say the constraint also. First thing is the function, and second thing is the condition. I'll denote it by phi. Phi of xy is equal to 0. Under this condition, we have to optimize this function. We have to find maximum or minimum value of the function. Previously, we discussed maxima minima, and for maxima minima, the stationary points we have calculated, and at those stationary points, we checked whether the function is maximum or minimum. Here, directly, we are not going to find out the stationary points directly. Indirectly, the stationary points are there. Without stationary points, we cannot move. Here, in this method, what we are going to do, we have to let the Lagrange function. I am going to denote it by capital F, and that will be u plus lambda phi. This phi is the condition, u is the function, and this is the Lagrange function. This is the Lagrange function, and where lambda is used, that is undetermined multiplier. That is undetermined multiplier. That's why this method is called Lagrange method of undetermined multiplier, either Lagrange method or Lagrange method of undetermined multiplier. Undetermined multiplier. Either you can say Lagrange method or Lagrange method of undetermined method. The problems are very simple. In almost all the universities, one problem is asked in examination. Now, the first one, previously we also discussed some problems on Lagrange method. I am going to start from problem number 1. Prove that the stationary value of the function x to the power m, y to the power n, z to the power p, this is p, under the condition x plus y plus z equal to a, is m to the power m. Okay, this is the problem we are going to solve. M to the power n, n to the power n, p to the power p, multiplied by a by m plus n plus p. This power m plus n plus n, m plus n plus p. Okay. Now in examination, m and p may be any integer. Any integer you will be given instead of m and p. In general, this a may be replaced by any other fixed constant in examination. The problem is very simple. Now, we are going to solve it. See, what we are going to optimize here, tell me. We are going to optimize, this is the function. Okay. And we are going to prove the stationary value of this under this condition x plus y plus z equal to a is this thing. Okay, stationary value means what? It is a minimum value or maximum value of the function. So what we are going to find out? The stationary value of this means let us denote this by u. Okay, I am denoting it by u. You may denote it by any other alphabet which is not repeated here. And phi is equal to, under this condition we have to optimize. Phi is equals x plus y plus z minus a. Okay, you can write it equal to 0 also. Now, I am going to Lagrange function I am going to write. Let the Lagrange function is u plus lambda times phi. Always function plus lambda times condition, in this way you can say. This is the Lagrange function. Now, the Lagrange differential coefficient del f phi del x, here I am writing del f phi del x I will find. So I am going to make the two parts of it because it should not be lengthy, you know. The solution must be covered in a single sheet. Del f phi del x. Then del f phi del y I will find, means derivative of f with respect to y. Del f phi del z I will find. Okay. What is f here? F is equal to x power m, y power p, n, z power p plus lambda times phi is what? X plus y plus z minus a. This is phi, right? Now del f phi del x. Del f phi del x is what? Derivative of f with respect to x keeping yz constant, means derivative of f with respect to x, m, x to the power m minus 1, derivative with respect to x keeping yz constant, plus lambda times derivative of z, x is 1, derivative of y is 0, derivative of z is 0, derivative of free constant is 0, means 1 is there. And equate it to 0. What we have done? Del f phi del x equated to 0. Now similarly, del f phi del y, take derivative with respect to y, n y to the power n minus 1, z to the power p plus lambda times derivative of this with respect to 1 x to the power m y to the power n p z to the power p minus 1 plus lambda times 1 equal to 0. It's very clear. Derivative with respect to z. Derivative with respect to z. Keeping other variables constant. Now this implies what? M x to the power m minus 1 as it is, y to the power n as it is, z to the power p as it is, and I am shifting lambda on the right hand side. Okay, we are going to simplify it now. Here n x to the power m y to the power n minus 1 as it is, z to the power p is as it is equal to minus lambda. Now x to the power m y to the power n z to the power p minus 1 multiplied by p is equal to minus lambda. Okay, means this equation equal to 0, this left hand side equal to 0, this left hand side equal to 0. So value of minus lambda I have calculated. Basically what we have to do, we have to solve these three equations. No? This equation and this equation. These three equations we have to solve to find out values of x, y, z. That's all. Find out the values of x, y, z. So you can solve it by your method also, but it should not be lengthy. You can solve it by your method. So what I am going to do is one of the way of solving these three equations. So here I found plus lambda plus lambda plus lambda. The value of lambda or minus lambda I found. Then I am going to equate all these values. Okay, equating values of lambda minus lambda, equating values of minus lambda. So what I'll get? M x to the power m minus 1 y power n z power p. Value of minus lambda is n x to the power m y to the power n minus 1 z to the power p. Value of minus lambda p x to the power m y to the power n and z to the power p minus 1. We have equated all the values of minus lambda, or you can equate value of lambda also and then minus you can cancel in that way, because these three ratios are equal, and when the ratios are equal, what to do? Here I am writing, okay, this step here I am writing. When the ratios are equal, then that is I am equating with, as it is I am writing, n z power p n x power m y power n minus 1 z power p equals p x power m y power n z power p minus 1. Okay, and this I am equating with proportionality constant k. This I am equating with proportionality constant because these three are equal. These are in terms of ratios. This divided by 1, this divided by 1. This. So I am equating with the proportionality constant k. Or you can equate it later on also. Okay, you can equate it now. But the right hand side unnecessary some adjustment of the terms we have to do. So what we are going to do? So we are equating this ratio when this ratio gets simplified. Now what I am going to do? Divide by what is the function? X to the power m, y to the power n and z to the power p. Okay, so I am dividing this by x to the power m, y to the power n and z to the power p. This divided by the same thing. This divided by the same thing. is it? Then the sum terms are going to cancel. This y to the power m, z to the power p gets cancelled. Here x to the power m, z to the power p gets cancelled. X to the power m, y to the power n gets cancelled. Okay, like that. Now what will remain here? M by x will remain. Here n by y will remain. And here p by z will remain. Okay. Now you can equate this with k, because this again ratios are equated. All are proportional. You can equate with k. But instead of equating, you can equate it k, no problem. But instead of equating k, in the next step I am going to equate. To make it simple, x by m, y by n and z by p. What I have done? I have taken the reciprocal of the ratios, means in ratio and proportion. If you take the reciprocal of the any particular ratios, you will get in ratio and proportion you get the same thing. Now I am going to equate with k. Okay, you can equate with k also here, but it will be 1 by k. That is also okay. And finally you have to find out the value of 1 by k in that way. Now if you equate these two ratios, the x equal to m into k, y equal to n into k, and z equal to p into k. Okay. Now the x, y and z you have obtained. So what remains to find? It remains to find value of k now, because when you use proportionality constant, the value of proportionality constant is required to be used in solution, and that is needed to be found. The value of k I have to find now. It is very simple to find out value of k. How do you find out value of k? Use condition. When you find out value of k, you have to use the condition. What is the condition here? The condition is what? X plus y plus z is equal to a. It's the condition. Okay, you may be given any condition. Stop this. Now x is mk, y is nk, and z is pk. Take k common, m plus n plus p is equal to a, and k equals a by m plus n plus p. Is it? So finally we found value of k. Stationary value of the function we have to find. The values of x, y, z we have to find, for which point this becomes stationary, and at stationary point you get maximum or minimum value. So here we have to prove that the stationary value of this is equal to this. So what I am going to do? So I am going to find out the value of x now. What is x? What is x? X is m into k. M into k means putting value of k. The k is a by m plus n plus p. Y equal to n into k. N, k is a by m plus n plus p. Z is pk. Putting value of k, a by m plus n plus p. Okay. Now these values of x, y, z, at this point the function becomes stationary. The stationary value means maximum or minimum value we have to find. Putting all those values in function, so you will get the stationary value, maximum or minimum value. The putting, therefore, the stationary value is what? X to the power m, x. This is x. to the power m, y to the power n, y is what? Na by this, and multiplied by z, pa by m plus n plus p. Okay, now this is equal to, so we have solved this problem, but in order to bring this one, it is very clear, m raised to power m, n to the power n, and p to the power p. Writing separately here, m power m, n power n, and p power p. Okay, this I have it. Now here a by law of indices, here a by m plus n plus p, a by m plus n plus p, a by m plus n plus p is common, and its indices are m and p. Therefore, in the indices will be added by law of indices. So this is the stationary value of this function. Under this condition, we have proved. Okay, we have proved. Is it? Very simple. What we have done, this is function, this is the condition. Write Lagrange function, putting value of u and phi, take partial derivative with respect to x, y, z, equate it to 0. Solve these three equations by your own method, or you can follow this also. Here minus lambda equal to left hand side, I have equated value of minus lambda. Then in order to simplify it, so I have divided this by x power m, y power n, and z power p, and we got simplified equation. And here one more step I have done, it is not necessary. The variable occurs in the denominator, so I have taken the reciprocal. Okay, the meaning of this will not get changed. If two ratios are equal, a by b equal to c by d, then that can be reciprocated. If you reciprocate it, means the value remains same, meaning remains same. Is b by a equal to d by c, like that. And then I have equated with proportionality constant. After that, the value of proportionality constant in this way I have found using condition. And finally, the value of x, value of y, value of z we have obtained. Then putting value of x, y, z, values of x, y, z here, you get the answer. Now, very quickly, the next problem we are going to solve. Okay, I'll be a little bit fast for it, because the same thing we have to do. The function and conditions will be different. Function and condition will be different. The second one, find the maximum and minimum distance find maximum and minimum distance of the point in the space is given. We have to find out maximum and minimum distance of this point from this sphere. The equation of sphere is given. Using Lagrange method. Using Lagrange method of undetermined multiplier or Lagrange method. Is it? Now, this is the sphere. Instead of sphere, you may be given anything. You may be given ellipsoid, you may be given cube, or like that. And there is a point, 3, 4, 12 is a point in the space. 3, 4, 12 is a point. Okay, this point is P, you can say. Okay, just I am giving the name to this point. And the minimum distance I have to find, this much distance I have to find, and the maximum distance, whatever the maximum distance from this point to the sphere we have to find. This distance and this distance we have to find. Okay. Now, when we are going to find out the distance, see, it is very clear. When we are going to find out the distance from a particular point to any surface, in general, the distance formula we have to use. Okay. Take any point on the sphere. Let A, X, Y, Z be any point. Is any point. That's why coordinates I am taking X, Y, Z. Any point on this sphere. The equation of sphere is given to you. A be any point on the sphere. Equation of sphere is given to you. Now, this A be any point, this point, this point, this point, this point, this point, any point. Okay. Now, distance AP I am writing by distance formula. Okay. So, x minus 3 whole square distance formula. It's very simple. In 8th, 9th class you have done it. Y minus 4 and Z minus 12 whole square by distance formula. Okay, this is the general distance we can say. General distance means what? It is distance from the point P to any point of the sphere. To any point of the sphere. And distance we are going to maximize and minimize. Means maximum distance out of those infinite distances. Out of all infinite distances, we have to find minimum distance and maximum distance. Is it? Means it is very clear that this distance function we have to optimize, distance function we have to maximize, or distance function we have to minimize. Okay. So when you deal with any function, as far as possible, if roots are there, you try to remove roots. Without removal, you can do it. But ultimately, we have to take the derivatives, and derivative of any root thing is a little bit complicated. As far as possible, you try to remove root, which I am taking square of this, x minus 3 square, same thing. I have taken square of both the sides, means root will get removed. Okay, so this is the distance, and this is a distance function, you can say. Square of the distance function. And now this I am going to maximize or minimize. Or maximize and minimize. Okay, so which is to be maximized or minimized? Let us denote that function by u. Okay, for convenience I am writing u. You can use any letter or any alphabet. This is the function which is to be optimized. Optimized means what? Maximized or minimized. And under which condition we have to maximize or minimize? Under this condition. Condition is what? This is condition is denoted by phi. In the last problem also, condition is denoted by phi and the function by u. The same thing I am using. X square, y square and z square minus 1. You can write it equal to 0 also. Not necessary. Okay. Now write down Lagrange function. What is the Lagrange function? Lagrange function is let Lagrange function f is equal to u plus lambda phi. This is the Lagrange function. Okay. Now what is u? U is x minus 3 square, y minus 4 square, z minus 12 square. This is u. plus lambda. Phi is what? X square plus y square plus z square minus 1. U plus lambda phi. U plus lambda phi. Is it? So without wasting time, I am taking derivative of this del f by del x. Derivative with respect to x, keeping other variable means y and z constant. Derivative of x minus 3 whole square I am writing here with respect to x. Derivative of this y term is 0. Derivative of z term is 0. Okay. Derivative of free constant is always 0. Lambda. Derivative of x square is 0. X square is 2x. Derivative of remaining term is 0 with respect to x. Here del fy, del y. Derivative with respect to y, 2y minus 4 plus lambda 2y, and del fy del z. Derivative is what? 2z minus 12 plus 2z. Is it? Now you can divide it by 2 and equate it to 0. Okay. After taking derivative with respect to x and x, y, z, we have to equate it to 0. It's very clear. Now x minus 3 plus 2 lambda x equal to 0. 0 equals, here 2y minus 8 plus 2 lambda y, same thing. 0 equals 2z minus 24. Here lambda I have not written, this lambda I have to put lambda into del f by del z, del f by lambda into derivative with respect to z plus 2 z lambda. Okay, you can divide it by 2 also here. Okay, I have divided it by 2, you can divide it by 2 also. It is your choice. Now try to simplify. See, there are two terms of x. X is common, 1 plus 2 lambda. This 3 I am shifting here. Okay, you can solve it by your way. Now, here y is common, y plus 1 plus 2 lambda. 1 plus 2, 8 I am shifting here. And 24 I am shifting in the left hand side. 2z is common. And 1 plus lambda. Okay. Now, here we have divided it by 2. This 2 should not be there, like this. Now, what is value of x? X is 3 by 1 plus lambda. What is value of y? 8 by 2 is 4 by 1 plus lambda. If you take 2y common, it should be lambda by lambda will be. And 24 by 2 is 12 by 1 plus lambda is equal to z. In this way, the values of x, y, z we have. Okay, very simple. Only simple calculations are there. See, simple calculations are there. Value of x, y and z. Now it remains to find out value of lambda. In last problem, what we have done, we have equated with k and value of k we found. Here the value of lambda you can find out. Okay, the value of lambda I am going to find. So how to find out it? Take help of condition. See, condition is what? X square plus y square plus z square equal to 1. X square is what? 3 by 1 plus lambda square, 4 by 1 plus lambda square, 12 by 1 plus lambda square. Putting value, because we are going to find out value of lambda now. See, try to simplify it. 1 plus lambda square, I am shifting on the right hand side, have a cross multiplication. 1 into 1 plus lambda square is 1 plus lambda square, I am writing. In the left hand side, 3 square means 9, 4 square means 16, and 12 square means 144. Is it? On the right hand side, lambda square a plus b whole square is equal to what? This is 1, this is 10, 9, is it? 5, 6, and this is what? 169. Okay. Shifting it on the right hand side, lambda square plus 2 lambda plus 1 minus 169 to minus 168 equal to 0. We want value of lambda, that's all. We want value of lambda. Now this equation I am going to solve. You can use calculator to get the value. You can use calculator or manually also you can solve. Lambda square plus 2 lambda minus 168 equal to 0. You can factorize it, just you can have the product of two numbers should be minus 168 and addition should be this one. So here, and once again I tell you, you can use calculator to get the values. Okay, 12 plus 14 minus 12 is plus 2 and product of 14 and minus 12 is minus 168. Is it? So if you take lambda common, lambda plus 14, if you take minus 12 common, lambda plus 14. Now lambda plus 14 is common, lambda minus 12. But I'll recommend you to use calculator directly. It means you can save the time because this you have done in previous years. In 10th standard, 9th standard, you have done like this. The two values of lambda we got, minus 14 and 12. So once you get the value of lambda, then put values of lambda here. That's all. Now, x equal to what? X equal to 3 by 1 plus lambda. Y equals 4 by 1 plus lambda. Lambda is minus 14. Z equals what? 12 by 1 lambda, right? Okay. Now, what is value of x here? Therefore, x equals 3 by minus 13. Y equals 4 by minus 13. And z equals 12 by minus 13. Okay. The values of x, y, z we have obtained for lambda equal to minus 4. Now, for lambda equals 12 I am writing. Okay, for lambda equals 12 I am writing. In this way I am putting sheet. Now, for lambda equal to 12, what is the value of x? X is equal to 3 by 1 plus lambda. Means what? 3 by 1 plus 12, 3 by 13. Okay. Y is equal to 4 by 1 plus lambda. And 4 by 1 plus 12 is equal to what? 4 by 13. And z equal to 12 by, z is what? 12 by 1 plus lambda. And 12 by 1 plus 12 is 12 by 13. Very simple. Means these are the values of x, y, z for lambda equal to minus 12. And these are the values of x, y, z for lambda equal to minus 14. In this way, we have obtained 2 points. Therefore, the 2 points we have obtained. What is the first point? 3 minus 13, 4 minus 13, and 12 minus 13 is the first point. Okay. And second point is what? 3 by 13, 4 by 13, and 12 by 13. Right? 12 by 13. So here, these 2 points we have obtained, and these 2 points are these points. Either this point is this one, A, and this point this one, or this point is this one and this point, like this. But we have to see, we have to check which point is the nearest point and which point is very far to that. Okay. For that purpose, what I am going to do, again distance formula I am using. Distance, which what I have used, AP, AP. Distance AP. Distance AP means this distance, Distance AP is what? Distance AP is what? This one. Because we are interested in maximum and minimum distance. X minus 3, y minus 4 square, z minus 12 square. 3, 4, 12. Okay. I am writing 3, 4, and 12. Okay. Now distance AP for this point, 3 by minus 13, 4 by minus 13, and 12 by minus 13. For this point I am going to find out the distance. Just you put x equal to this, y equal to y coordinate, and z equal to z coordinate. Okay. 3, 4, 12, that point is there. From the point 3, 4, 12. Okay. And this is the point on the sphere. This is the point on the sphere. So find this distance and using this formula and find this distance. 3, 4, 12 and 3 by 13, 4 by 13, 12 by 13. Is it? So find these 2 distances. If you use distance formula and if you find the distance, okay, so here the maximum and minimum distance you will be getting, and the maximum distance you will be getting 14. One of the distance you will be getting 14 and other distance you will be getting 12. It is very clear. So once you get 14 and 12, this distance 14 and 12, so it is very clear that this is minimum distance 12 and this is the maximum distance. Okay, in this way we have solved this problem. Now we stop here. Thank you very much.